At the far edge of our solar system, past Neptune, past the last of the planets most people can name, a small, frozen world has been sitting quietly for billions of years. Most people stopped thinking about it after 2015. The year a spacecraft called New Horizons flew past it for a few brief hours, sent back its photographs, and moved on into deep space. Since then, Pluto has mostly been treated like a closed case. A demoted planet, a frozen rock with a heart-shaped glacier and not much left to discover. Then, the James Webb Space Telescope looked again, and in the data it sent back, scientists found something that didn't match anything in the scientific record. Not on Pluto, not anywhere else in the solar system. To understand why that's such a big deal, you have to understand what Pluto actually is. Not the simplified version most of us learned growing up, but the version scientists have slowly pieced together over the last 2 decades. Pluto was discovered in 1930 by a young astronomer named Clyde Tombaugh, working at Lowell Observatory in Arizona, comparing photographic plates of the night sky night after night, searching for a single faint point of light that moved against the background. Stars, while everything else around it stayed fixed in place. It took him nearly a year of painstaking, repetitive searching before he finally spotted it. A discovery that made headlines around the world and added a 9th planet to the solar system almost overnight. For most of the century that followed, that's essentially all Pluto remained. A faint dot, too small and too distant for even the most powerful telescopes on Earth to resolve into anything more than a blur. That changed in July 2015 when NASA's New Horizons spacecraft became the first, and so far only, mission to fly directly past Pluto. In a matter of hours, humanity went from a blurry dot to detailed photographs of mountains, glaciers, and a pale, hazy atmosphere wrapped around a genuinely active little world. Cameras captured towering water ice, mountains rising several kilometers into Pluto's thin sky, a vast, pale plain of frozen nitrogen shaped almost perfectly like a heart, and dark, reddish terrain unlike anything scientists had modeled beforehand. Then the spacecraft kept moving, racing on toward the outer edge of the Kuiper Belt, and Pluto went quiet again. But Pluto isn't just a ball of ice drifting in the dark. It has an atmosphere, thin but real, made mostly of nitrogen, with traces of methane and carbon monoxide. And high above its surface, that atmosphere does something almost no one expected before New Horizons. It produces haze, layer upon layer of it, stacked in a faint blue glow, visible even in those first grainy photographs beamed back across billions of kilometers of empty space. For years, that haze was little more than a beautiful mystery. Scientists could see it. They couldn't fully explain what it was doing or why it mattered. One team thought they had an answer, almost a decade before anyone could test it. Back in 2017, a planetary scientist named Xi Zhang at the University of California, Santa Cruz proposed something that struck many of his colleagues as almost too strange to be true. He suggested that the tiny haze particles drifting through Pluto's sky weren't just a visual feature. He believed they were actively running the planet's climate, absorbing sunlight during Pluto's long day, then radiating that heat away after dark, acting less like ordinary atmospheric gas and more like a planet-sized air conditioner, quietly regulating a world nearly 6 billion kilometers from the sun. At the time, there was no way to test it. The instruments that existed simply weren't sensitive enough to separate the faint thermal glow of Pluto's haze from the glow of its enormous companion moon, Charon, which orbits so closely that the two bodies practically blur together at a distance. For years, the idea sat there, plausible, elegant, and completely unconfirmed, a hypothesis waiting for an instrument that didn't exist yet. Many of Zhang's peers were openly skeptical. The prevailing view in planetary science had always held that gases alone regulate a planet's atmospheric temperature, not solid particles suspended within it. Suggesting that haze itself could dominate an entire world's energy balance meant challenging an assumption that had gone largely unquestioned for decades. Then, in 2022, the James Webb Space Telescope turned its instruments toward the outer solar system. Webb's mid-infrared instrument, tuned to wavelengths between roughly 5 and 28 micrometers, far too faint and far too specific for most telescopes to bother with, was finally sensitive enough to do what nothing else could. Using its 6.5-meter mirror, it separated Pluto's thermal signal from Charon's cleanly for the very first time, capturing the faint infrared glow of the two worlds as two distinct light curves instead of one blurred smear. A team led by astronomer Tanguy Bertrand at the Observatoire de Paris spent months analyzing that data, comparing it against thermal models built to test exactly the kind of haze-driven climate Zhang had proposed years earlier. And when researchers examined what it captured, the numbers matched Zhang's decade-old prediction almost exactly. The haze wasn't just decoration, it was the mechanism regulating Pluto's entire atmospheric temperature, heating and cooling the sky above it in a way no other atmosphere in the solar system is known to work. One of the scientists behind the discovery didn't hide his surprise. In Planetary Science, he said, it's genuinely rare to see an idea confirmed this cleanly, this many years after it was first proposed. But confirming the haze theory was only the beginning of what Webb found. Because once scientists understood what the haze was doing, they noticed something else, something that raised an entirely new question. Pluto's atmosphere is leaking. It has been for a long time, quietly losing gas into space, thanks in part to that same haze. The particles absorb solar energy and, in doing so, give nearby gas molecules enough of an energetic kick to escape Pluto's weak gravity altogether. Pluto is small enough, and its gravity weak enough, that molecules near the top of its atmosphere don't need much extra energy at all to break free entirely, drifting off into the vacuum of space rather than settling back down toward the surface the way they would on a larger world like Earth or Mars. That process alone would be strange enough on its own, but Webb's data revealed something stranger still. Some of that escaping gas doesn't simply drift off into empty space. It travels a short distance across the void, separating Pluto from Charon, roughly 19,000 kilometers, close enough that the two worlds are often described less as a planet and moon and more as a true double system, and lands there instead. Material is physically transferring from one world's atmosphere onto the surface of its neighboring moon. As far as anyone knows, that isn't happening anywhere else in the entire solar system. It may even explain something astronomers have wondered about since Charon was first photographed up close. The moon's north pole is stained a strange, dark reddish color, unlike anything else on its otherwise pale, icy surface, a feature so distinctive that the New Horizons team gave it an informal nickname referencing one of literature's most infamous shadowed lands. For years after the flyby, that dark cap was simply a striking visual oddity in the photographs, discussed and debated but never fully explained. Scientists now suspect that color comes directly from Pluto's breath. Methane escaping the dwarf planet's atmosphere, drifting silently across space, then getting chemically transformed by sunlight once it settles onto Charon's frozen ground, decade after decade, orbit after orbit, slowly staining the same patch of ice a little darker with each pass. A planet, quite literally, changing the color of its own moon. That connection sent researchers looking even more closely at Charon itself. And in 2024, using Webb's near-infrared spectrograph, a team led by planetary scientist Sylvia Protopapa found something that had evaded detection for decades: carbon dioxide and a second compound, called hydrogen peroxide, both present on Charon's surface for the first time in the scientific record. Neither compound is exotic on its own, but finding them there for the first time, after nearly 50 years of studying this small, icy moon, filled in a gap in Charon's chemical story that scientists had been trying to complete since the moon was discovered in 1978. At the distance, Charon orbits the sun. Surface temperatures rarely climb above, roughly minus 220 degrees Celsius, cold enough that chemical reactions, which would happen instantly on Earth, can instead take centuries to unfold, frozen in place, layer after layer, like a slow-motion record of everything that has struck or settled on that surface since the solar system was young. Researchers believe these compounds may be preserved evidence of the violent process that created Charon in the first place, billions of years ago, along with clues about how radiation from space has been reshaping its surface ever since. Two worlds, locked in orbit around each other for over 4 billion years, are still actively exchanging material and chemistry today. That alone would have been a remarkable enough discovery for one mission. But it isn't the strangest thing Webb found out there. Buried in Pluto's spectrum, the detailed breakdown of light that tells scientists exactly which molecules are present in an atmosphere, researchers noticed something missing. Not a new signal appearing where nothing had been before, but a specific narrow band of light simply absent, in a place where known chemistry says nothing should be missing at all. Every molecule leaves its own signature in light, a set of exact wavelengths it absorbs as sunlight passes through it. Scientists use that signature the same way you'd use a fingerprint at a crime scene. Match the pattern, identify the compound, move on to the next question. Researchers checked out Pluto's missing signal against every cataloged molecule they could think of, working back through decades of published spectra from labs and observatories around the world, cross-referencing databases built up over generations of laboratory chemistry experiments designed specifically to catalog exactly this kind of signature in advance. None of them matched. Laboratories on Earth can recreate many of the extreme conditions found on distant worlds, the cold, the pressure, the specific mixtures of ices and gases, and measure exactly how those materials absorb light under controlled conditions, building the very catalogs astronomers rely on to identify what they're seeing millions of kilometers away. For this particular signal, none of that existing laboratory work lined up. That would already be strange enough on its own, one unidentified gap in the spectrum of a single distant world. But then scientists checked a completely different object, more than 1 billion kilometers away, orbiting a completely different planet, Titan, Saturn's largest moon. And there, in Titan's atmosphere, the exact same missing signal turned up again. Two worlds could hardly be more different from each other. Pluto is a small, frozen dwarf planet drifting through the emptiness of the Kuiper Belt, warmed only faintly by a sun that looks like little more than a bright star from that distance, with surface temperatures cold enough to freeze nitrogen solid. Titan is a moon over 4 times more massive, orbiting a gas giant instead of the sun directly, thick with a hazy orange atmosphere denser than Earth's own, and famous as the only other place in the solar system known to have rivers, lakes, and rain made of liquid methane instead of water, carving shorelines and river deltas that NASA's Cassini spacecraft mapped in detail over more than a decade of close observation. They don't share an origin, they don't share location, they don't obviously share much chemistry at all. One is a captured or co-formed dwarf planet in the outer solar system, the other a moon that has orbited a gas giant for billions of years, shaped by entirely different histories of heat, radiation, and formation. And yet, somewhere in both of their atmospheres sits a molecule unlike anything documented anywhere else, not on any other planet, moon, or exoplanet ever studied by any instrument. Researchers, combing through the scientific literature, found no reference to any known compound absorbing light at that specific wavelength in any previous study on any world. Whatever this is, it appears to be genuinely new to science, hiding in plain sight in 2 of the coldest, most distant corners of our solar system. That's the discovery generating the most excitement and the most caution among the scientists studying it. An unidentified molecule isn't proof of anything exotic on its own. It could turn out to be a known compound behaving in an environment scientists haven't modeled correctly yet, or a mixture of substances producing a combined signal no one has replicated in a laboratory. But right now, nobody has a confirmed answer. And in a field built on matching signals to known chemistry, an unmatched signal is exactly the kind of loose thread scientists can't simply set aside and move past. It also raises an uncomfortable question that reaches far beyond Pluto and Titan. Astronomers increasingly rely on exactly this kind of spectral matching to study planets orbiting other stars, searching the light passing through distant atmospheres for the chemical fingerprints of water, oxygen, or even possible signs of life, sometimes trillions of kilometers away. If 2 worlds inside our own solar system, places humanity has already visited with spacecraft, already photographed in extraordinary detail, can still produce a signal nobody can identify, it's a sobering reminder of how much remains unknown even in our own cosmic backyard, let alone in atmospheres too distant to ever visit directly. Confirming what a molecule is here, close to home, matters far beyond Pluto itself. So why does any of this matter beyond satisfying curiosity about 2 frozen worlds at the edge of the solar system? Because Pluto's haze-driven climate, strange as it sounds, may be quietly rewriting scientists' understanding of a period in Earth's own history that left almost no direct evidence behind. Billions of years ago, long before oxygen filled our atmosphere, Earth's air was dominated by nitrogen and hydrocarbon chemistry, not entirely unlike the chemical mixture drifting through Pluto's sky today. That early atmosphere left almost no direct physical trace behind. Rock and ocean chemistry offer only indirect clues about what the sky above ancient Earth actually looked like, or how it behaved. Studying how haze particles regulate temperature and chemistry on a world like Pluto gives researchers a rare, present-day laboratory for understanding conditions that may have shaped Earth long before life as we know it existed, back when our own planet's sky may have looked far stranger and far hazier than the blue one we take for granted now. In other words, a small frozen world nearly 6 billion kilometers from the sun might be holding clues about the very origins of the atmosphere that eventually made life on Earth possible. That's not a connection anyone expected to find when New Horizons captured its first grainy images of Pluto a decade ago, a spacecraft built primarily to map surfaces and measure basic atmospheric composition, not to uncover clues about the deep history of a completely different planet 90 million miles closer to the Sun. And scientists aren't finished. Webb's observations of the Pluto Cairn system are ongoing, with researchers hoping to fill remaining gaps in Cairn's chemical inventory and pin down exactly what's producing that unidentified absorption feature shared with Titan. Every additional observing window adds another layer to a picture that keeps growing stranger the closer anyone looks. Future proposals are already being drafted to point Webb back at both worlds, this time targeting the specific wavelength ranges the current data couldn't fully cover. There's also a broader question sitting underneath all of this. Pluto is only one object among an estimated trillion or more icy bodies believed to exist in the outer reaches of our solar system in the vast, largely unexplored region known as the Kuiper Belt, a region so distant and so dimly lit that even Webb, the most powerful space telescope ever built, can only examine a handful of its largest members in any real detail. New Horizons visited exactly one other Kuiper Belt object after Pluto, a small contact binary world nicknamed Arakoth, and even that flyby only scratched the surface of what that distant region contains. If a single, relatively small world out there is capable of producing a completely unidentified molecule, actively transferring atmosphere onto its own moon, and running a type of climate system unlike anything else humans have measured, scientists are left wondering exactly how many other surprises are waiting in that same distant region, untouched by any spacecraft, unseen by any telescope until now. For most of the 20th century, Pluto was little more than a faint dot in even the most powerful telescopes on Earth. Discovered in 1930, downgraded to dwarf planet status in 2006, photographed properly for the first time only a decade ago, and treated for most of its existence as a footnote at the edge of the solar system rather than a world worth studying closely. That's no longer true. What Webb has revealed is a small, distant world running an atmospheric system unlike anything else humans have measured, exchanging material with its own moon in a way found nowhere else nearby, and hiding somewhere in its thin, cold air, a molecule that doesn't match anything in the scientific record. And this is a world we've already visited, a place humanity has already photographed up close, already mapped in detail, already assumed not so long ago that we understood completely. Somewhere in the archives of that 2015 flyby, in images studied and restudied by scientists, for the better part of a decade, the seeds of this mystery were probably already present, embedded in the faint blue haze photographed on Pluto's limb without anyone realizing exactly what it was doing or what it was hiding. It took a different telescope, 7 years later, sensitive to wavelengths, New Horizons was never built to see, to finally start pulling that thread loose. If Pluto, small, cold, and long since demoted from the list of planets most people learn as children, can still hold a genuine unsolved mystery hiding in its atmosphere, it's worth pausing on what that says about everywhere else we haven't looked as closely. Every world we think we finished studying may simply be waiting for someone to look one more time with sharper eyes than the ones that looked before. And in the case of Pluto, the next look may already be enough to prove that a small, frozen world at the edge of the solar system still has secrets no one has fully explained.